Dear learners, greetings. Today we are going to discuss the uses of normal probability curve. As already have been explained and told to you that normal probability curve has a lot of characteristics, a lot of peculiarities. So in today's lecture we will see what are the uses of normal probability curve. So there might be so many uses of normal probability curve, out of which the first use we are going to see today, and this first use is related to determine the percentage of cases in a normal distribution within given limits. That is, two limits have been given, two scores have been given, and you are required to find out the percentage of cases. So the first example you can see, given a distribution of scores with a mean of 12 and a standard deviation of 4, assuming normality, calculate what percentage of cases fall between 8 and 16, what percentage of cases lie above score 18, and what percentage of cases lie below score 6. So let me repeat the problem. A normal distribution has been given, mean has been given as 12, standard deviation has been given as 4, and you are required to find out the percentage of cases which fall between the score 8 and 16. You have to calculate what percentage of cases lie above the score 18 and what percentage of cases lie below score 6. So first let us do the first part of this problem, that is percentage of cases lying between 12 and 16. So you see, this is the mean which is given 12. You have to calculate between 8 and 16. So between 8 and 16, see, sigma is what? Sigma is what? 4. Right. Now remember, if 12 is the mean, then this score 8 will come here, that is mean minus 1 sigma is equal to 8 in this case, and score 12, score 16 will lie here, that is mean plus 1 sigma, and you are required to find out the percentage of cases lying between 8 and 16. It means in this particular case you have to find out the percentage of cases between mean plus 1 sigma and mean minus 1 sigma. And remember, when we taught you about the characteristics of normal probability curve, we told it that the area in the curve is 68.26% between mean plus 1 sigma and mean to minus 1 sigma. That is the percentage of cases that lie from mean plus 1 sigma to mean minus 1 sigma is 68.26%. So the percentage of cases in this particular problem which lie between 8 and 16 has finally come out to be 68.26%. So here, if you want to see the table, again you might confirm it. I am taking a pause. You open the table and consult the table. Definitely you will find that mean plus 1 sigma and mean minus 1 sigma, the percentage of cases will be 68.26%. So let us move to the second part of the problem. So what is second part of the problem? You are required to calculate the percentage of the cases which are above 18. So above 18, here what you have to do? You have to use this master formula. So what is this formula? Z is equal to x minus m upon sigma. So let me repeat, Z is equal to x minus m upon sigma. So what is x? the raw score which is required to be converted into Z score. And what is M? M is the mean score that has been given in this particular problem, and sigma is the standard deviation which again has been given in this problem. So, mean we know, that is 12, sigma we know, that is 4, and x, that is 18. 18 is required to be converted into Z score. But remember, in statistics there is a rule that whenever we go to upper score, we add 0.5, and whenever we go to lower score, we subtract 0.5. So, in this particular case, since we are moving above 18, so instead of 18, we will take the score as 18.5. So, let me repeat. It is a rule in statistics that whenever we take the higher limit, we add 0.5. Whenever we take the lower limit, we subtract 0.5. Since in this particular case, we have to calculate the percentage of cases above 18. So, instead of 18, we will take it 18.5. So, x in this particular case is 18.5. So, put the values in that formula and simplify. So, the moment you will do it, you will subtract 12 from 18.5, whatever comes you will divide by 4. So, finally you will get 1.625. So, Z score that you have got for this particular problem is 1.625. Now, remember what you are required? You are required to find out the percentage of cases above 18. Now, here after calculating the Z score, you will open the table. So, I am taking a pause. You open the table of normal probability curve. In this table, see the first column, scores are given. Now, you see what is the corresponding area in that table according to 1.62. Let me repeat. Open the table, see the first column, locate 1.62 and see what is the corresponding area before that point, that is 1.62. So, the moment you will see, you will find that it is 44.74. Note it. What I am saying? That corresponding to Z score 1.625, the area which is there in the table is 44.74. Now, remember what you have to calculate? You have to calculate the percentage of cases above 18. So, for that again draw a normal probability curve. The moment you will draw a normal probability curve, you just locate where is 18. So, if it is 12, that is mean, and sigma is equal to 4. So, 18 will be here. So, remember what you have to calculate? You have to calculate this area which is above 18. Now, remember, it is a peculiarity, it is a characteristic of the curve that this mean line divides this whole curve into two equal parts. That is, one part will have the area 50%, another part will have the area 50%. So, this whole area is 50%. But you are required to the shaded area. So, when whole area is known to you 50 and this particular area you have got as 44.74, then it is easy for you to locate that area, to calculate that area which is shaded, that is which is above 18. So, what you will do? 50 minus 44.74. So, finally you will get 5.26%. So, 5.26% cases in this particular case will lie above score 18. So, two things you have to remember. Number one, the moment you are calculating above any score, So don't forget to add 0.5 to that particular score. Since here we are interested in finding out above 18 score, so we will add 0.5 to 18. So this is one point. Another point, remember that you have to find out the shaded area, and you know that the mean line divides this curve into two equal parts. So area of one part will be 50%. So first by seeing the table, you will calculate the area, you will find the area, and then by subtracting that area from 50%, you will get the required area. With this, let's proceed to the third part of the problem. So this was first part, this was second part. Now we have third part of that is below score 6. Now draw normal probability curve. So this is mean 12, sigma is equal to 4. We have to calculate, locate 6, and below 6 is this area, below 6. So what you have to calculate? You have to calculate this shaded area. Modus operandi will be same. First convert this 6 into Z score, find out this particular area, and subtract this particular area from 50%, definitely you will get the required area. So first calculate the Z score for 6, and don't forget to subtract 0.5, because in this particular case we are moving towards below score. So instead of taking 6, we will take 5.5. Rest of the formula, that is Z is equal to x minus m upon sigma, it will be same. But in the previous case, since we were interested in above score, so we added 0.5. Here we are going below that particular score, so it will be 0.5, you have to subtract. So 5.5 minus 12 upon 4, you will simplify it. So finally you will get 1.625 with negative sign. And remember, negative sign indicates that you are moving towards left hand side. If you are getting positive side, it means you are moving towards the right hand side of the mean in the curve. But if you are having the negative sign, it means you are moving towards the left hand side of the mean in the curve. So here, since your score is 6, which is less than your mean 12, that's why you are getting the negative sign, and this negative sign shows that you are moving towards the left hand side of the mean in that particular curve. So this particular area, just open the table as in the previous case you have done. Open the table, see the first column, locate 1.62 and see the corresponding area. So you will find it 44.74%. That is from this to this, that is from mean score to 6, the area you have calculated as 44.74. But what you are required to do, you are required to calculate the area which lies below 6. So for that, what you have to do, you have to subtract 50 minus this particular area. So finally you will get this area which is required. So you will subtract 44.74 from 50, and that by that way you will get 5.26. And why you have subtracted from 50? Because this mean line divides the whole curve into two equal halves. So one half area will be 50%, another half area will be 50%. So this is how we do it. Let's take another problem and proceed ahead. I have taken the second example, and now given a distribution of scores with a mean of 20 and a standard deviation of 5, assuming normality, calculate what percentage of cases fall between 12 and 24, and then what percentage of cases lie below the score 10, what percentage of cases lie above the score 28. So it's very simple. what percentage of cases fall between 12 and 24? So for that you calculate 12 into convert 12 into z-score, convert 24 into z-score. So find out the z-score for 12 and for 24, and accordingly you see the area in the table, find out the sum of these two, and that will be equal to the percentage of cases which fall between 12 and 24. What percentage of cases lie below the score 10? So here what you will do, it's very simple. Below 10 means you will take the score 9.5. So you convert it into z-score. So 9.5 minus mean, that is 20, upon sigma, that is 5. You will get the z-score. Accordingly you consult the table, find out the area, and whatever the area you are getting, subtract from 50. So you will get the case, percentage of case which is below the score 10. Similarly, what percentage of cases lie above the 28? So in the above 28, what you will do? What percentage of cases lie above the 28? So in this case, what you will do? Definitely, you will first take 28.5. So 28.5 minus 20 upon sigma, that is 5. So you will calculate z-score, and after getting the z-score, accordingly you will find out the area, and whatever the area you are getting, you will subtract from 50, and finally you will get the percentage of cases. So in a nutshell, if I say this is the first use of normal probability curve, that some scores have been given and you are required to find out the percentage of cases. So between this score to this score, if this is the situation, definitely convert both the scores into z-scores, and whatever the z-score you are getting, you consult the table and find the sum. It's very simple. If it is there that you have to calculate above some particular score, so 0.5 you have to subtract in order to get the z-score. After getting the z-score, see the area and subtract it from 50, so you will get the required percentage of cases. Similarly, if it is given below this particular score, again you have to first subtract 0.5 from that particular score in order to get the z-score, and after getting the z-score, what you will get, you will consult the table, and after consulting the table, whatever the area you are getting, you will subtract it from 50. So finally you will get the required score. So this is the first use of normal probability curve. Now tomorrow we will proceed ahead and we will see the second use of normal probability curve. That is, in this particular case, scores have been given and you have to find out the percentage. But tomorrow we will proceed to another use of normal probability curve, in which we will see that percentage of cases have been given, but we have to find out the limits, and again you will find it very interesting. So thank you very much for staying with me. Let's meet tomorrow to see the second use of normal probability curve. Thank you.